Let's start chapter number 19, Reactions of Organic Compounds. Chapter overview, comprehensive exploration of organic compound reactions, focus on alkanes, alkenes, ethanol, and carboxylic acids, examination of chemical transformation and industrial application. Some learning objectives here includes understanding reaction mechanism of different organic compounds, explore manufacturing processes for ethanol, analyze chemical properties of carboxylic acids and esters. Alkanes, some fundamental characteristics. Key properties include generally they are unreactive chemical compounds. They are readily combustible. They undergo substitution reaction with chlorine, and photochemical reaction mechanism is also observed. Next is substitution reaction. Chlorine interactions occurs through photochemical processes. Specific reaction conditions required for transformation. Let's talk about alkenes reaction mechanism. In production methods, it is obtained through catalytic cracking. It participates in addition reaction. Its structural transformation is also possible. Now let's talk about ethanol. Comprehensive analysis, production methods, catalytic hydration of ethene, non-renewable resource origin, that is petroleum. Some advantages are it has continuous process, fast reaction time, high purity yield, and sophisticated manufacturing technique. Fermentation method. This is also renewable source origin. Advantages: simple production process, potentially carbon neutral and environmentally friendly approach. Uses of ethanol. Industrial solvent used in paints, glues, perfume, printing ink. Fuel applications. Burns with clear flame, high heat output, blended with petrol, gasohol. Potential alternative to traditional petroleum fuels. Some combustion reaction. Here you have which produces carbon dioxide and water. Then we have carboxylic acid. Chemical characteristics. Structural definition, its functional group is COOH. So COOH are carboxylic acids. Homologous series of organic compound. First two acids, methanoic acid, HCOOH. So inside carboxylic acid, you have methanoic acid, and then you have ethanoic acid. All right, let's talk about these first two acids. Methanoic acid found in nettle and ant stings, liquid at room temperature. Then let's talk about ethanoic acid. Primary component is vinegar. It's a weak acid with weak properties, solidifies at room temperature. Reaction mechanism, it reacts with reactive metals, bases, and metal carbonates. Then we have oxidation process. Ethanol gives us ethanoic acid. Oxidizing agent, warm acidified potassium manganate 7. Then we have nanotechnology insights, molecular innovations, Carbon nanotubes as microscopic test tubes. Potential medical applications, drug delivery mechanisms, targeted cellular intervention. Organic compounds, reactions, and characteristics. Let's talk about alkanes, overview and its properties. Chemical characteristics, fundamental properties. They are saturated molecule, generally unreactive, cannot participate in addition reaction, unaffected by acids or alkalis, and can undergo substitution reactions, especially with chlorine. Let's talk about some fuel properties. Natural gas components. Methane is the primary component obtained through petroleum fractional distillation. Burn exothermically, which means it releases significant amount of heat. Now let's talk about fuel varieties. Compressed natural gas CNG, cleaner alternative to petrol, used in vehicles like motor coaches and auto rickshaws. Let's talk about liquefied petroleum gas LPG. It's a mixture of propane and butane, kept liquid under pressure. Used in heating system, portable stoves and gas lighters. Some combustion reactions. Complete combustion produces carbon dioxide and water vapor, requires sufficient oxygen supply. Incomplete combustion produces carbon monoxide, which is a toxic gas, creates carbon particles, soot, major cause of air pollution. Some substitution reactions include chlorine interaction. Here, hydrogen atom replaced by chlorine atoms. Photochemical reactions requires ultraviolet light and produces chloroalkanes and hydrogen chloride. Key reaction types. Here we have photochemical reactions. Now we have characteristics of photochemical reactions. Activation energy provided by light. Typically they are having ultraviolet wavelengths and specific to certain molecular interactions. Some important terminologies for you guys to learn for examination perspective. Number one, substitution reaction, replacement of atoms without changing molecular structure. Then photochemical reactions, chemical reactions activated by light energy. Then we have saturated molecule with single bonds between carbon atoms. Now let's talk about safety and environmental consideration. Carbon monoxide interferes with oxygen transport in blood. Incomplete combustion contributes to air pollution. Fossil fuel combustion has significant environmental impacts. Now, let's talk about some organic compounds and their reaction. Cracking reactions, overview of cracking. Process, breaking down long chain alkane into shorter molecules. Key characteristics of cracking. It produces shorter alkanes and alkenes. It generates hydrogen as a byproduct. It occurs over a hot catalyst, typically aluminium oxide. Then we have laboratory cracking procedure. Equipment, medicinal paraffin oil, heated catalyst, delivery tube, safety valve, Bunsen valve. Products and uses. Alkane products, blended into gasoline, shorter chain length. Then we have alkene products, raw material for various industrial processes, can be polymerized into different materials. Then we have ethene transformation pathways. Here we have alkene reactions. Number one, combustion. In this reaction, alkene burns in sufficient oxygen. Products carbon dioxide and water vapor. The equation is here, which is producing carbon dioxide and water. Then we have bromination addition reaction. In bromination, characteristic is breaking down double bond of carbon. Indicator decolorizes bromine water. Result colorless product with bromine atoms added. Now let's talk about hydrogenation process, adding hydrogen across double bond. Catalyst, nickel is used. Temperature 150 to 300 degrees centigrade is maintained. Industrial application used in margarine production. Now let's talk about steam hydration reaction, adding water across alkene double bond. Catalyst, phosphoric acid. Conditions, high temperature, high pressure. Now let's talk about ethanol production method. Here we have fermentation, organisms, specific yeast, conditions, anaerobic process, temperature between 25 to 35 degrees centigrade, self-limiting, stops at 14% concentration, reaction in front of you, it is producing ethanol and carbon dioxide. Let's talk about industrial synthesis. This is C6H12O6 gives 2C2H5OH plus 2CO2 as a product. All right, let's talk about industrial synthesis. So method, catalytic addition of steam to ethene. Then catalyst, immobilized phosphoric acid. Conditions 300 degrees centigrade and 6000 should be the pressure. Some key terminologies: hydrogenation, addition, reaction, adding hydrogen across double bond. Then we have hydration, adding water elements across carbon-carbon double bond. Then we have fermentation, chemical process using living organism to produce compounds. Some important reaction considerations: alkenes are more reactive than alkanes due to double bonds. Product formation can depend on bond location. Isomers may produce different reaction outcomes. With this, we have finished this lesson. See you in our next lesson.